Hi everyone, welcome back. We are looking at absolute value inequalities, and this is the third type you would run into, and this is one that students tend to mess up the most. So we have the absolute value of negative 4x plus 3 is greater than or equal to negative 9. So again, our solution is going to start off by writing the equation verbatim. And then what we're going to do is we're also going to have to write the 4x plus 3 verbatim again, but we're going to change the sign of the inequality and change the sign of the number. So that we are looking at negative 4x plus 3 greater than or equal to negative 9, or negative 4x plus 3 is less than or equal to 9, and we have to solve both of these equations. So let's do that. So the first one, we're going to subtract 3 from both sides of the equation. These will cancel, leave a negative 4x. This is supposed to be greater than or equal to negative 12, so dividing both sides by negative 4. So remember that we're dividing by a negative, so we have to switch the sign of the inequality, so this will be less than or equal to a positive 3. Well, on the other hand, we are going to again subtract 3 from both sides, and these will cancel again. We'll get a negative 4. This time it's less than or equal to a positive 6. And dividing both sides by a negative 4, we get that x should be greater than or equal to negative 3 halves. So this is an or statement. So we should look at the number line here. So here's 0, and here is 3. And so x being less than or equal to 3, well, let's graph that. So this will be this point here and everything to the left of it. Let's look at the other inequality. The other point here is negative 3 over 2, and then we graph everything on it. So we're going to have the solid dot here and everything green to the right here. And so the solution then is, where did we shade in? Because the whole idea of or means, in a sense, dump everything into a bin. So basically, you think of all the numbers less than or equal to 3, you throw them into some bucket. You take all the numbers that are greater than or equal to negative 3 halves, and you throw them in some bucket, and you see what you have in the bucket. Well, that's what I did with the number line. The red represents what we threw in for less than or equal to 3, and the green represents what we did for greater than or equal to negative 3 halves. And notice that this actually gets us the entire number line. So our solution then is all real numbers. And notice that these problems won't always give you all real numbers as a solution. Mine just turned out to happen to because my absolute value inequality was greater than or equal to a negative number, and that always happens when the other side of the equation is a negative number. So, but the basic procedures all work the same way. So we'll leave you here, and then we'll move on to the videos for the next class period. See you then.